So, we're going to be doing light, reflection, and refraction. So, now, we're going to be doing about the first lesson on light, which was about reflection. Not the other lesson which has about refraction, but it is a light lesson, so yeah, you don't need any worries. So first of all, what is light? Light is a form of energy. So this energy is what helps us to see things. So we're able to see things around us because of this energy. So how do we see these things? We're able to see these things only when light falls on them, and this light falling on them reaches our eyes. So, we know we have luminous objects like the sun, light bulb, and many more. So, these are all examples of luminous objects. We see them because they emit light. So let's say we have the sun. We are able to, I'm just drawing it. We're able to see it because the light from the sun reaches our eyes. But however, what happens for non-luminous objects? How do we see non-luminous objects? So, we're able to see non-luminous objects because when the light from such a luminous object falls on a non-luminous object such as a book or a wall, then this light, a part of the light, gets bounced back from this non-luminous object. And when this bounced back light reaches our eyes, then we are able to see the non-luminous object. So it's just a simple ideology which you can remember. So it's this bouncing back of light is called reflection, as many of us know. Alright, so as we're done with reflection, now let us move on to types of surfaces. Not surfaces, what can I say? Categorization types, whatever types are there. So in types, what happens is that, oh my god, my screen. So there are three types mainly. We can say transparent, opaque, and translucent. Many people say a mirror is another type, but since it doesn't allow any light to pass through, so we can just say it's opaque. So first let us move on to transparent. So what is a transparent surface? It allows almost all the light to pass through it but reflects very little light. Now, translucent means it's faint. You can see through it, but it is faint. Then opaque means it does not allow any light to pass through, but it absorbs very little part of the light. So it reflects most of the light. Now, after we're done with opaque, let us move on to regular and diffuse reflection. So, what do you mean by regular and diffuse reflection? In regular reflection, what you do is that, wait a minute, wait, let me off my media for a second. Yeah, okay. So in regular reflection, so all the light falls on a polished surface, and like when the surface is so smooth, the entire beam gets reflected only in one direction. And this is called regular reflection. So because the mirror surface is so smooth, the light that is falling on the mirror surface gets reflected only in one direction. However, if we look at diffuse reflection or irregular reflection, it happens when the surface is not so smooth. This is because we have the surface, right? The surface is rough, so it's going to get reflected in different directions. So this is called irregular reflection. But however, this is also very important because when we have irregular reflection, it's because of this irregular reflection of sunlight that we're able to see many of the objects around us. So when sunlight falls on this, it gets irregularly reflected and we're able to see it even though our room does not get sunlight properly. This is called irregular reflection. Now then let us look at about the laws of reflection. So, there are mainly two laws of reflection. So the first law states that we have the mirror, then when an incident ray strikes the mirror, when a ray of light strikes the mirror, the ray falling on the mirror is called the incident ray. And the point at which it strikes the mirror, this one is called the point of incidence. Now, the point from the ray of light which gets reflected from the point of incidence is called the reflected ray. Then, the perpendicular to the mirror, the point of incidence, is called the normal. So, now the angle between the normal and the incident ray is called the angle of incidence. And the angle between the reflected ray and the normal is called the angle of reflection. So, if we see here, there is an angle which is getting halved, right? So, you notice that these two angles must be equal, right? So that is the first law of reflection. So angle I is equal to angle R. Now, the second law of reflection means that the incident ray, the reflected ray, and the normal all lie in the same plane. I had to go 3D to show this to you guys, but let me show you. Let's say this is the mirror. Alright? Then when the incident ray strikes, the reflected ray goes, we have the normal. Now when you notice, if you place them, if you draw them on a sheet of paper, you notice that all of them lie on the same plane, which is the plane of the paper. It is not going to go backwards away from its plane, but it's actually the incident ray and the reflected ray can be connected from each other on the same line. So this is the second law of reflection. That the incident ray, the reflected ray, and the normal all lie on the same plane. Now, let us move on to the properties of the image formed by the plane mirror. So, we already learned in class 7 that the image that a plane mirror forms is virtual. So, the plane mirror always forms a virtual image, which means that it cannot be formed on a screen. So, let us look at the properties. So, the plane mirror also forms an image that is virtual, it's erect, it's of the same size as the object, and it is at the same distance behind the mirror as the object is in front of it. You might have witnessed this. So when you stand in front of a mirror, if you walk forward towards the mirror, your image also walks forward. If you walk away from the mirror, the image also walks away. See, it's so simple to understand. Now let us move on to the lateral inversion. It's another property of the image formed by plane mirror, and it means that there is an interchange of left and right. Whenever you stand in front of the mirror, when you raise your right hand, your image always raises the left hand. So, this is because of lateral inversion, and there is an interchange between left and right. Now, let us move on to multiple reflection. So what is multiple reflection? When you have two or more mirrors and you have a reflection between them, it results in a large number of images to be formed. For example, let's say you're in the washroom and you notice that there are two mirrors behind. One mirror in front and one mirror behind you, and this is you in the middle. You'll notice there will be many images of you, like infinite images of you, a large number of. So this is because of multiple reflection. So the image formed by one mirror acts as the object for the second mirror, and it goes on and it goes on and it goes on. So this cycle continues. So this phenomenon is called multiple reflection. So this means that an image of an image is formed. So if you want to determine the number of images that are formed, you need to use the formula 360 by theta minus 1. What do you mean by this formula? So here 360 is the degree. Then theta means any angle, the value of the angle is 40 degrees, 60 degrees, 90 degrees, or 120 degrees like that. Then mostly we use 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees for theta, as you learned in trigonometry. Yeah. So let's say the angle between the mirror is 0 degrees, so 360 degrees by 0, which is equals to not defined, infinite, and you can't do this. So yeah, so this means that the number of images formed is infinite. Now when you have 360 by 90 minus 1, so degrees, so 0, 4, which is equals to 4 minus 1, which is equals to 3. So 3 images are formed. So as the angle between the mirrors keeps on decreasing, then the number of images keep on increasing. So yeah, 90 degrees, 30 degrees, like that. So this is the formula. Where is this formula used? Of course, a kaleidoscope. A kaleidoscope. What is a kaleidoscope? It is actually a toy which many of us might have played played with in which multiple reflection is used. It consists of three mirrors that are striped together and they're placed in a box along with some colorful bangles in the cylindrical box which can rotate. So as you rotate the cylindrical box, the three mirrors form multiple images of the bangles and they form beautiful patterns. And as you rotate it, the pattern shifts continuously. So now we'll learn about the last thing, which is uses of plane mirrors. So what are the uses of plane mirrors? So we know that a plane mirror, when a plane mirror is used to during outdoor shooting by using metal sheets to reflect sunlight on actors, and in the solar cookers to reflect light on the food being cooked to heat it up to make it more hotter. Then it is also used in periscopes. I mean, this is an interesting thing you guys must see. So it's like this. So I think 60 degrees angle at 60 degrees. So when there's light coming, it's used in submarines. The light coming from the top of the sea, like this is the sea, the periscope always sticks to the top. The light coming from the top hits this mirror and it gets reflected and bounces back, and you know by laws of reflection it goes straight down. Then it hits this mirror and goes like this, and there's an eye over here who sees it, and he sees what are all the images over there. See, like this is simple. You can try this at your home where there's a mirror. Like if you stand diagonally, you're gonna see what's over there. So yeah, it's used in periscopes. Then, like it's used in our homes to look at our reflection, and also in beauty parlors. What do they do there? In beauty parlors, the mirrors placed at an angle are used to view the side of our head. And mirrors placed parallel to each other are used to view the back of our head. Alright, so see, we have completed the light chapter. So that's it for this video, guys. And I'll see you next time in the next video. Please like, share, and subscribe. Bye. Bye-bye, bye-bye, bye-bye. Come in the next video. I'm going to be doing a cubing and a drawing video. Bye-bye.